Kia ora, good day everyone, and today we'll be talking about AWS Local Zone updates, which recently launched in Auckland. My name is Bayu, and I'm a consultant with the Instillery. For the next 20 minutes, I'm going to do an update on what is AWS Local Zone, what features does it brings, what are the use cases, and also a bit of demo on how that works. Okay, so let's take a closer look on that. And before we dive into the details, let's quickly review the agenda on what we're going to cover for today. So we'll start off with what is actually an AWS local zone, what are the features and the use cases, and also a bit of followed by a demo after that. And then based on demo, we're going to compare between AWS Sydney region and also Auckland region and see, for example, like from feature point of view, cost, and also latency, which is pretty interesting. And we're going to sum up with summarize and what are the key takeaways based on today's discussions. Okay, I hope you're excited, and let's jump straight in. So the first section I'm going to talk about is what is actually local zone. What is the features looks like, and what's the use case that it's trying to solve. So if you notice the recent announcement, which is earlier this month, as you can see here, it was May 1st, 23, which I believe this is in US time zone. So it's available in Auckland. You can now use AWS Local Zone to deliver applications that require single-digit millisecond latency or data processing. And as you can see here, this is also taken from the AWS Local Zone website. It's saying the zone name is AP Southeast to AKL, and the parent region is Sydney. But what does that mean? So I have a diagram here. So if you imagine that now, for example, us here in New Zealand, the closest region for New Zealand will be um, in Australia, for example, in Sydney. There's another one in Melbourne, but for today we'll be talking about Sydney. So, you know, when a region is a bit kind of far away from your location, from user locations, which in our case, probably typically around 30 to 50 milliseconds, that can be like a bit too far for the users or for the application. So, and that normally means that the customers or organizations will need to provision, manage, operate a physical infrastructure in on-premise or in data center, but maybe not everyone, not all customers, not all organizations want to manage and operate a physical infrastructure. In fact, I was talking to a few customers that they want to get rid all of the physical infrastructure at their on-prem data center. So what local zones bring now, that local zone is launched uh, in Auckland, New Zealand, and we can now extend the region. That's why it's called parent region. We can extend the parent region down to Auckland side or Auckland location, so we can deliver single-digit millisecond latency and local data processing. So that's kind of in high level. You might be wondering how does the architecture looks like. I have that on. We'll take a look here. So, for example, if we're going to provision or use some public cloud services in Sydney region. We will have an AWS account, and we'll select a region like Sydney region in this example, and we can start deploying services like S3, DynamoDB. But for services like EC2, for example, you would need to spin up a VPC, and then after that, you set up multiple subnets across different availability zones to ensure some redundancy, and deploy EC2 instance, for example, into those subnets. Now, as I mentioned previously, that with local zones, you can now extend this parent region, extend this VPC down into Auckland. And you might notice here that that's kind of actually looks similar to additional availability zones, because it's a subnet, and you can deploy resources into local zone. Well, in fact, actually, a local zone, once you enable it, which you will see later, once you enable a local zone, it will look and behave like very similarly to like additional availability zones. Yeah. So, so that's the overall architecture, and I think like the next logical questions will be like, what kind of features that it supports, or what use cases that it's trying to solve. Let's see from the features point of view first. There's a link here if you can to look at the comparison between the features. Uh, but as you can see, it supports a numbers of services and mainly cater for services that requires a low latency. And and so, for example, here LA being the first local zone that was announced, it actually supports more features than other local zones. And also LA, there are multiple local zones, and that was introduced a bit later. So it didn't support all of these features from day one. And if we take a look at Auckland here at the bottom, so it has less features as of now. We'll see if it will support more features later down the road. Uh, but one thing to notice that it's it supports some a different type of instances compared to LA, for example. So make sure to check first uh, what instances that you're planning to deploy, and also like uh, EBS. So for EBS, it supports GP2 as of today. And just a reminder, GP2 actually you need to plan out your volume depending on your IOPS requirement, because like GB is around 3 IOPS, which is kind of different with GP3. So that's a few things to note, and that's the overall features. And from a use case point of view, based on that features, and if you've seen maybe like AWS Twitch TV or AWS reInvent, they actually mainly they mention this three. There are three main use cases that AWS Local Zone is trying to solve. One is latency sensitive apps. So if you have like applications that quite uh, sensitive to latency, you can use local zones. Another one for hybrid cloud migrations, because if you want to migrate like in a piecemeal strategy, then you can migrate slowly so that it has a lower latency between the cloud and your on-prem location. And another one is around data residency. So data residency, I think you may need to work out your requirements and what are the features that's supported. Because, for example, if you're planning to deploy resource on AWS S3, for example, S3 still need to be deployed in the parent region. But if you're just using maybe EBS or like in LA, it's FSX, you can deploy that in a local zone. And for example, some of the some of the case studies here that I've taken from AWS website, like esports engine, they use local zones for deploying a single-digit millisecond latency using AWS local zone. Because you can imagine if you're playing a game, online game, especially maybe a first-person shooter or any other online, if there's some lag and there's some latency, I think you won't kind of get a chance to win the game in the first place. So that's for gaming. And another one, this one is related to hybrid cloud migrations, which is from memory, they do a slow migration, and they want to do bit by bit, and AWS Local Zone helps them to minimize the latency between applications and local zone and on-prem. And the last case study here that I want to highlight is around content creation used for remote workstations. Uh, so if you're not familiar with this, I have a slide here. So this is about cloud a virtual workstation. So when it comes to creating like digital content or image processing, VFX editing, anything like requires image processing that normally requires a high powered machine or computer, and that can be expensive, especially if you need to use a physical laptop or physical machines. Now, with the power of the cloud and with G4 instances, you can actually deploy EC2 instance with GPU back, like G4 instances, and now like the visual artists can or editors, they can just stream pixels and not just secure, but you kind of pay as you go. You can just pay based on the resource that you want to use. But you can imagine that like this kind of streaming or like interactive, that requires a low latency. So it maybe there's not so much point if you can deploy that on demand, but latency is quite high because you kind of need to be interactive, like maybe drawing in a tablet or editing. You need to keep playing audio, video back and forth. If there's a delay, that's not really good for user experience. So with local zones, in this example, like Blackmagic, they use they stream the pixels and they deploy G4 instances backed by GPU, and they use FSX on local zone. So for LA, FSX is supported in the local zone, but I think for Auckland, that's not supported yet. So hopefully that's coming soon. So, and maybe I think maybe that's enough for the theory for now. Are you keen to see how do we actually enable a local zone and how to deploy a resource there? Before I jump into my AWS console, in terms of enabling an AWS local zone, it involves kind of two steps. One, you go to EC2 console, enable the local zone, and after that, once enabled, you can start creating subnets into a local zone. As you can see here, it looks like another availability zones. And if you're going to like provision an EIP, public IP, make sure that you are on the right network border group. So let's jump into the AWS console here. So from the AWS EC2 console on the right hand side here, so this is not VPC, but EC2 console, you would go to zones and make sure you're on the right region. Then from there, you can select, here I have enabled the local zone, but if it's disabled, you go to there, manage, and select enable, and you hit update zone group. So and once it's once updated, then you can create a subnet from here and select that subnet as in the Auckland local zone, like in my example here. And to launch services like EC2, it's again pretty much like an additional local availability zone. So you can go to EC2 console, in my case, and start selecting the EC2 instance type. And you can check the available instance type through AWS CLI, or you can actually like filter based on the zone name. So based on the zone name here, like you put AKL, and that's it will list the available instance type on that local zone. And after that, you go to the right VPC. I have my own VPC, and select the right your desired local zone. And once that launch, so I actually have provision to EC2 using Terraform, and I have installed a container to run a speed test. And let's quickly take a look. So this is one instance in Sydney, and the other one is in Auckland. So let's do a quick speed test, and just for the sake of time, I'll just run both around at the same time. So as you can see here, it's about 40 milliseconds latency, and that's through my laptop. That's through a wireless, which again, there's some latency for wireless. So if you're doing through a cable, that may go up, sorry, may go down, a better latency, but that's in Sydney. And here, like that's through I think this from because of the wireless, but from my previous test, it goes around like between 3 to below 10 milliseconds. And if I actually do I'm curious if I do another test how that's, because I'm not really good in my Wi-Fi connection is not that good, but just in general, this is through wireless. It has a lower latency compared to the Sydney region. So that's just a quick overview. And if you need more, if you want more details on that, happy to cover more deep dive on that. But just to give you an idea comparing. So based on that, this is what I mentioned before, that from AWS EC2, AWS CLI, you can do a describe instance, and you can list what are the available instance type. And as you can see, the Auckland actually has less instance type compared to Sydney. So make sure to check what are the supported EC2 instance type before you're starting to deploy them. It's like plan ahead. And same with from a cost comparison point of view, it actually has different pricing. Like as you can see here, it's around 0.07 for Auckland and 0.05 for Sydney. So, and you calculate monthly, that's of course that's a bit different. And so this is just a high-level diagram to summarize in terms of latency. Actually, this is based on my previous test from my home network, which I kind of get around 5 milliseconds. But now from the place where I test, I have a bit trouble with my Wi-Fi, so it has higher latency compared to here, but still lower latency compared to the Sydney region. So that's pretty much that I want to cover for today. And in summary, we take summarize what we've covered so far. So AWS Local Zone, again, it extends the parent region. Like in our case, we can extend Sydney down to Auckland region and delivers low latency. In some cases, it can do a single-digit latency. In my case, because I'm through Wi-Fi, so there's some additional latency because of the Wi-Fi. And unlike AWS Outpost, where you need to manage an infrastructure, like with Local Zone, you can deploy without any infrastructure, but deliver a low latency. So use cases for latency-sensitive applications, hybrid cloud migrations, for data residency. But again, for data residency, make sure you check the requirements and check what features are supported. So for example, like S3, that's still in the parent zone. So not all services are available in Local Zone. And last but not least, like the Direct Connect is actually available in Auckland location, and you can hook it up to Local Zone if you need a private connectivity to a Local Zone. So for tens of milliseconds of latency, you can deploy in a parent region. But for now, if you need low latency, you can start to think maybe if you need to deploy use cases that requires low latency, you can start deploying or leveraging Auckland local zone. So that's all that we want to cover for today. I hope that's really informative for you, and I hope to see you in the next session. If you have any question about local zone or want to know more about the networking design, please let us know in the comments, and we'll be happy to cover it for you. Thank you very much.